Hello, AI learners. Have you ever wondered how chatbots like Claude or ChatGPT are able to respond to your questions? This is done using a technology called Conversational AI. What exactly Conversational AI is and how you can build your own AI agents is something that we'll discuss in this video. In simple terms, Conversational AI is a set of technologies that allows machines to process, understand, and generate human language. And conversational AI is revolutionizing the way we interact with machines. Today, in 2024, we're able to build intelligent systems that are able to reason through complex problems using these large language models. And because of this, the applications of conversational AI in industry are growing every day. Imagine, for example, a world in which businesses can provide 24/7 customer support without breaking a sweat, or in which you have a personal assistant that you can ask anything and it will be able to follow up and break down your questions into low-level instructions that you don't need to worry about. And we're just skimming the surface right now. Agentic AI is going to take the world of business by storm. So whether you're interested in building AI applications or you want to start your own AI automation agency, now is the right time to start. Historically, though, conversational AI systems were quite a pain to build and maintain. You needed to have specific AI systems for natural language understanding, for dialogue management, for the knowledge base, and to generate a response. Today, with the advances in natural language processing, we now have large language models that can do all these things. But they have a problem. They have a knowledge cutoff. Large language models are typically trained on large data sets, but once you start training a large language model, you're no longer able to add more information to that model, which means that some of the biggest and most state-of-the-art models out there, they only know the world up to 6 or 8 months ago. How we're solving this in industry is by giving our large language models access to external information, which we do by providing them with tools to query databases and search the internet and search documents and all kinds of other external data sources. So in the demo, we're going to build a conversational AI agent using Python, LangChain, and internet access. You might wonder why exactly we're using LangChain. Well, first of all, LangChain is a Python framework, there's a lot of people out there that are able to code in Python. Second, it provides a high-level abstraction that allows us to build very complex agentic workflows. It also has a big and very active open source community, which means that there are integrations available for almost all commercial large language providers and a lot of the tools and databases to which you want to give your large language models access. And lastly, it has some features out of the box that you need in conversational AI applications like memory and tool use. All right, so this is our Google Colab notebook. It's a free online environment in which you can run Python code. There's good documentation out there. I won't go into details here. And we're going to build our LangChain agent using a prompting pattern called React, which will make sense in a little while. There's more information in the link here if you're looking to read up on what exactly this prompting pattern is. So we needed to install some Python packages in order to run our code, most importantly LangChain and OpenAI, but there's a few others. And then we import the Python objects to our notebooks. And what we also need is an OpenAI API key. This is sort of a password that you need in order to make sure that you're allowed to run queries against the OpenAI clients. We've set this up already in our secrets here, and then we import it in our notebook. For more information on how to exactly generate an OpenAI API key, you can follow this tutorial here. But remember that if you want to run this notebook and follow along, the usage of OpenAI APIs does cost some money. It's not a lot. It's going to be a couple of cents, even less. But still, you need to be aware of this. All right, so with that set up, we can now instantiate our LLM client, so our large language model client. And the model that we'll be using for this tutorial is GPT-4o, which we specify here. And then we use that using a LangChain wrapper called for the OpenAI API client and the API key that we just created. So let's run this. And let's see what happens when we ask it what the latest training data is that available in the large language model. There we go. So according to GPT-4o, its training data includes information up to September 2021. So it's even earlier than we said at the beginning. Let's see if that actually makes sense. So we'll ask it. So we'll ask it a different question. whether or not the opening ceremony of the Paris 2024 Olympics went according to plan. As of the recording of this video, that happened last weekend. So let's see what the LLM says. And here we do see the same data from the table, that the last update that it had for its weights was in October 2023. So what is happening here is that we're asking the large language model about its future, a future that did not yet happen according to the large language model. That's also what we see in the answer. But it is aware that its data is not up to date. All right, so like we said, one way to solve this is by giving our large language model access to external data. And we do this with what is typically referred to in the industry as tool usage, where we give our large language models tools it can use to query external data sources, and sometimes even perform actions on those external data sources. In our example, we're using Wikipedia because that's one of the few tools for which you don't need an API key, and I didn't want to make this notebook any more complicated to set up. But there are a couple of good free internet search tools in the LangChain library that you can use for which you do need an API key, but that won't cost you any money to run. So here we set up our tools, and now we're going to give our large language model, which was, as you remember, OpenAI's GPT-4, access to those tools. In this case, it's a single tool, but okay. So let's ask the question again to our LLM with Wikipedia access. But it looks like it's not giving us an answer. It did, however, as you can see here, call a tool. It called the Wikipedia tool with the following arguments, as a search query, Paris 2024 Olympics opening ceremony. But it had no way to process the response because it didn't know how. As you can see as well here in the content, which is the output, the message that the user would see, it's blank at the moment. So in order to make sure that the LLM actually knows what to do when it gets a question from a user, we need to provide it with a template of how to respond. And this is where the React prompting pattern comes in. We already mentioned in the beginning. So this is a prompting template that tells large language models the steps they need to take when receiving an input from a user. First, in this case, we show it what tools it can use, and then we instruct it what it should do with user questions. One of the important things in the React framework is the reflection step here, where the large language model needs to decide which tools to use and how to use them. These are the actions. And then once it runs an action, so once it runs a tool and gets an output, it needs to check if the output answers the user question. And it can do this a number of times until it gets the right answer. What we're also doing in this prompt template is that we're giving it access to conversational history, which you can use as additional context, so users don't need to input the same information time and time again. So we've set up the template here, and we're also going to pass it a memory object, which is a way to store the message history in Python. And then we create our agent, and we pass it in a LangChain wrapper with the tools and the memory, along with several other settings. Here we go. So let's see what happens now when we run our agent. Let's see. So as you can see, it's doing something different from before. It's following the React template to answer the user question. So it's thinking about what to do. So it's decided that it will need to search for recent information on this topic. And it does so by using the Wikipedia tool and providing the following search query, Paris 2024 Olympics opening ceremony. As you can see here in the user input, that's not what it said there. It's reformulated it to a proper search query. In light blue, what you see is the output of the query tool. So in this case, think of the output of the query tool as the list you see when you do a search in Google. So these are the top X results from a search on Wikipedia that the agent now has access to. So it retrieved a couple of results, including a summary for the page on the opening ceremony, along with a summary of the page for the Olympics themselves, and a summary of the page for the 2012 Summer Olympics opening ceremony. And based on the information it retrieved from Wikipedia, it was able to formulate an answer. So, and that's what we'll see here. So, according to our agent, the opening ceremony went according to plan, but it did receive mixed reviews and was marred by external events, including an arson attack on the railway system. And this is information that it couldn't have had in its training data, so we're sure that it's gotten this from this external source. And because we added memory to our agent, we can also ask follow-up questions, and it will understand it based on the context of the conversation. So if we ask it, for example, how is the weather? It will know that the answer is about the opening ceremony of the Paris 2024 Olympics rather than how was the weather yesterday, for example. So it's ran this query. As you can see, it's a different query from before. So it added the weather word there to search for this. And if you have a tool that can search the internet, this will matter a lot. In the case of Wikipedia, there is no separate page for opening ceremony weathers. So it will just retrieve the same page again. I tried again with a different, it also tried to run the same tool again with a different formulation to see if it could get better results based on the output from the first query tool run. And apparently in the summary that it's retrieved, there was no detailed weather conditions for the opening ceremony. So let's see what it answered. So apparently this information was not available. So there you have it. We've covered the basics of conversational AI and created our own conversational AI agent using LangChain. How easy was it, right? It was just a little over 10 lines of Python code, and you have something that can query the internet, reason through complex problems, and generate responses for you. Just think of the possibilities if you build more complex and advanced systems. In some of our upcoming videos, we're looking at multi-agent systems, where multiple agents are combined to create even more complex workflows. But you can probably already think of some use cases yourself. For example, if you add internet search to the agent that we have in the notebook, what would happen? Could you maybe get it to automate some of your research tasks? I don't know, but you can probably think of some interesting use cases yourself. So keep learning, keep experimenting, and who knows what might come out of it. And if you enjoyed this video, don't forget to like and subscribe, or if you have any questions, leave them in the comments below.